Hello everybody, welcome back to Physical Science. This is kind of where we left off. We talked about the three different classes of elements on the periodic table. Okay, so the three classes we talked about we already talked about this, but metals are one, they're all conductors. But not all conductors conduct the same, as easily as the next conductor, right? They say, what's the best conductor? Gold is really, really good. I don't know about copper, silver, and gold. They're all really, really good. The reason why people use gold is because it doesn't corrode, so it doesn't react as much as copper. So you can put it under the ground. If you're going to have wires under the ground for a long, long time, you might make them out of silver or gold because they don't corrode as much as copper. But all three of those, and notice, look on your periodic table. So as you're looking at your periodic chart then, what are you noticing about copper, silver, and gold?
Right underneath each other.
They're in the same column. Very good. Rows are side to side, columns are up and down. Now that's one of the things we talked about yesterday, is how each thing in a column is going to have similarities to the thing above and below it, right? When we did that little periodic table thing, we saw that, hey, these all have the same kind of hair, or the same triangle, same... Remember yesterday's little deal? So that means that all these things are going to be very closely related in their chemical reactivity. These things will be closely related, and really, they're all closely related to each other in this up and down column form. Okay. But now, I'm just going to look at these metals over here. And now, one thing I wanted to clarify from yesterday, we said we had the zigzag line, right? And we said to the left is the nonmetals, to the right is the metals, or straight that, reverse it. To the left is the metals, to the right is the nonmetals, right along the line is the metalloids. But look at this. What's over here? Hydrogen gas. So that isn't a metal. But interestingly enough, chemically it reacts sometimes as if it's a metal, and sometimes it reacts as if it's a non-metal. So this is the one that goes both ways. In our current theory, scientific theory on the universe and things, this is the first elements, and then combinations of these elements, the hydrogen and then other bigger elements, make up all the rest of the elements. And where does that happen? In the stars, right? In the stars, in the nebula, which is where stars are born, or where stars die. That's where all this huge energy is, this high temperature, smacks these particles together and makes new atoms.
Sure.
So metalloids then, is another thing we already talked about. These are called semiconductors. Sometimes they border the zigzag lines. This is all stuff we've already talked about, right? Yeah. And then finally we get to the nonmetals. I believe this is where we kind of left off talking. So nonmetals are to the right of the zigzag line. Most are gases at room temp. They're not shiny. They're not malleable. They're not ductile. Remember we talked about those words, malleable and ductile. Malleable is pounded into sheets. Ductile is stretched into wires. That sounds like metal. Okay? So this is kind of where we're starting today, then, determining electron configuration. And I will tell you, you're only going to get a very small part of the story today. When you determine the electron configuration, you're going to be looking at the energy levels of the electrons. Keeping in mind, the electrons are not really on levels, but they're at energy states around the nucleus of the atom. And determine valence electrons. And we'll put the number of the valence electrons. The valence electrons are always on the last energy level. Okay, so we're going to have to make some sense out of that. So this is kind of Okay, so we're going to see if we can follow these directions and put our electrons in energy levels. Okay? So we're going to try to follow these directions right now. I'm going to do it off to the side. So let's look at phosphorus. Okay, phosphorus. So phosphorus, the first thing you're going to want to do is put phosphorus, right? Because that is the letter for phosphorus, right? So look at phosphorus. What's your atomic number for phosphorus? What's the atomic number?
15.
15. Everyone see that, right? Because here's phosphorus. Right here, atomic number 15. Okay. Okay. So we know that phosphorus then has 15 electrons. So you might want to jot that down somewhere. Let's say, okay, I'm going to just put this off to my notes. 15 electrons. That's how many I need to put on the energy levels for phosphorus, right? So now, so number one says, determine the number of energy levels. So that's the period it's in. So what period is phosphorus in? 3, right? Because we have period 1, period 2, 3, and if you look all across, there's phosphorus. So that means we have to have 3 energy levels for phosphorus. Okay. So, I'm going to just draw the 3 energy levels as like dashes right here. Okay? So it means there's going to be 3 energy levels for phosphorus. Now number 2 says, determine the number of valence electrons and put that number on the last or the highest energy level. So, how do you determine valence electrons? We talked about that 2 days ago. Do you remember? This column has 1 valence electron. This one has 2. These we're going to talk about later. This is 3, 4, 5, 6, 7, and 8. Do you guys remember that?
Yep.
Okay, so phosphorus is going to have 6 valence electrons. Now the valence electrons are the most important electrons because those are the ones that are involved in all chemical reactions. Okay? So these are the ones that we're going to do all of our chemistry figuring with. So what did we say phosphorus had? It had 5, right?
Yeah.
Is that what we said?
Yep.
Okay, so 5 in the outermost energy level. Do you understand that?
Yes.
Okay. Now, if you remember yesterday or the day before, we said, and you better write this down again if I didn't explain it, or the first energy level has how many electrons?
1.
Can 2 electrons. The first energy can hold at max 2 electrons. If it's hydrogen, the first energy level only has 1. If it's helium, the first energy level has 2. Okay? The second energy level, how many did that hold? 8. Very good. So you found that in your notes, right? 8 electrons. Okay? And then at max, the third had how many? 18. Very good. 18 electrons. And then the fourth at max has 32. Okay? And there are some other parts to this story. And I may or may not explain that to you now. It's kind of a chemistry thing. But, so we have 15 electrons that we have to file according to their energies. We know that we have 5 of them in the highest energy level that phosphorus could have and can have, it does have. So now, we start at the first energy level. Okay, that can hold 2, right? So I can put 2 more. So I'm going to place 2 more electrons here. So now I have 7 electrons that I have filed according to their energies. How many do I have left to file? No? Because 15 is what I had to put in.
Oh,
Minus 7, I have 8 electrons left. So that's That's where we put the rest, in the second energy level. So this is electron configuration according to electron energies. You will be asked to do this for a worksheet today. Do you have any questions? Okay, good. So then we have to talk about one more electron configuration, because there's other ways to configure electrons. And that is determining electron dot diagrams. I'll let you write down these notes. Number 1 says determine the number of valence electrons, which you know how to do that. Number 2 is print dots around symbol. Now I'm going to make a little bit of change on this rule here. This rule says making sure every side has 1 before any has 2, but the new rule is the right side has 2 first, and then all the other sides get 1 before they have 2. Okay? So I'll show you how to do that after you write that down. Okay, let's give this a try. So let's start with hydrogen. Okay? How many valence electrons for hydrogen? 1, right? Because it's in the first group. So there it is. 1 electron. Okay, let's look at helium. How many valence electrons does helium have?
2.
Okay, this is a trick question, because if you look at the periodic table, you will see that helium is over here in group 8 or 18 or 8A or 18A, depending on your periodic chart. So you want to say that it has 8, right, according to what we said? The problem is helium only has how many electrons?
1.
2!
That's 2.
Because, you know, the atomic number is 2, which is the proton, so by default it's got to have 2 electrons. So, this is a little bit different story here. Helium only has 2, and there they are. So this is the electron dot configuration for helium. So let's look for silicon. Silicon, okay? Okay, so what period is silicon in? I mean, what group is silicon in?
4.
Here it is right here, right? Well, it's in group 14 or 4A, depending on your periodic chart, but it's going to have 4 valence electrons. Do you agree?
8.
Okay. So the way that silicon valence, or the way that silicon's dot diagram would be 1, 1, 2, 3, 4. Why? Okay, I'll answer that. So silicon has 4 electrons, right?
Yep.
So the correct dot configuration would be this, 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 and this.
So I looked at the other.
When it goes, which I'm sure you're going to be happy to know that when silicon goes to bond with other materials, a lot of times this electron will fill in a different sublevel, and it will act as if there's one on each side.
Ah.
Okay, so let's go up with xenon. How many electrons does xenon have in the valence level? 8. So the correct way to fill that in would be like this, and then finally like that. And that's the electron dot configuration for xenon. Let's do boron, which has what? 3, right? So the correct one would be like this.
I get it.
Okay? Let's do practice this now with a worksheet.
Okay.
Hopefully this helps.